Hello, this is your last set of notes for chapter 1. So that's exciting for you. And we're going to talk about inequalities today. So where are we going to start here? First, we're going to talk about some vocab. Inequalities are obviously not equal. In means not, like incomplete, not complete. These are not equal. So we're dealing with no equal signs. This guy is a less than. If you want to remember, if you straighten out a less than sign, it will make an L. That's a less than. This is a greater than sign. This will be a less than or equal to, or a greater than or equal to. This is technically also an inequality sign. It does not equal, but we're going to be dealing with the less than, greater thans today. When you solve it, you're going to have a whole bunch of values that will be true. So for example, an x is greater than equal to 5. A lot of times when there's a lot of solutions that make something true, we will graph it using a line. We would put 5 on our number line here. And the solution is the picture of the graph that is making it true. So it can be 5. So we do a solid dot here. On your math lab, sometimes at the 5, they will put a square bracket. A square bracket is the same thing as a solid dot. And what numbers are bigger than 5? Well, 6 is bigger than 5. 7 is bigger than 5. All these numbers are bigger than 5, so we would shade it to the right. And your text on MathLab might do it like this. So that's how you can show a graph of what an inequality solution looks like. And then if they want you to do it in a solution set of notation, interval notation, they will say, okay, so all the solutions are 5, and it can be 5. So we'll use a square bracket to infinity. So that is the answer to the solution set. If it was something like this, where it was x is less than, let's say 3, you can still graph it. This time for 3, we would do an open circle because it can't be 3, but it can be really close to 3. And it would be numbers like 2 and 1 and 0 and -1. So this would be our picture. Again, your math lab will do it a little bit differently. They'll put a parenthesis here instead of a square bracket, and it will be shaded this way. And what values can this be? And we're going to do this notation again of what it can be. We do the small number first, so it's going to be negative infinity. We always do a parenthesis by the infinities because you can't get there. And then till 3, and we're going to do a parenthesis this time because you can't get to 3, but you can get really close to 3. So these are the ways that you can write the solutions. You solve inequalities just like you solve equations. The only difference is this multiplication property. You can add to both sides, multiply by both sides, and all that stuff, but this is the big guy right here. When you multiply or divide both sides by a negative number, you have to flip the inequality, and here is why. Everyone agrees that 5 is bigger than 2. The multiplication property says you can multiply both sides by 7. Let's say we multiply both sides by 10, and it will still be true. 50 is still bigger than 20. But if you take 5 is greater than 2 and you multiply it by -10, you're going to get -50 and -20. -50 is further to the left than -20 on a number line. So instead of a greater than sign, when you multiply by a negative, you have to flip the inequality so that it's pointing the opposite direction. That's the number one mistakes kids make with inequalities, but other than that, they do pretty well. Moving on here, let's do some practice. So let's practice solving these inequalities and then graph the solution set. We're going to get our x's together. So I'm going to add the 2x first. And I'll have 5x minus 5 is less than 6. We'll add 5 to both sides, and that's 11. 5x is less than 11. Divide both sides by 5, and we can leave it just like that. X is less than 11/5. If you wanted to change it to a decimal, you can. It'd be like 2.2, but I'm going to leave it as an improper fraction. Okay, so you'll graph it. You'll make your number line. We'll put 11/5 on it. If you want to put 0 on these, you can, just as a notation to where you're at. It's not going to get a square bracket. It's going to get a parenthesis. And where are numbers less than 11/5? That's to the left, this direction like this. So the values will be negative infinity to 11/5, and I'm going to do a parenthesis instead of a square bracket because it does not equal. Let's take a look at this guy. Let's get our x's together first. It's kind of messy here. So let's go ahead and subtract 10x. I'm going to subtract 10x from both sides. So I have 13 minus 17x is greater than or equal to -4. Got to move the 13 over here. Some of you might have gone a different route than me on this, and that's okay. Subtract 13, and I get -17x greater than or equal to -17. Now's where I have to be careful because I'm saying the words divide both sides by -17. Because it's a negative, I'm going to have to flip the inequality for the reason we talked about a minute ago. So I'll have to reverse the sign, and it's x is less than or equal to 1. So if you graph it, we'll put 1 on the number line. It'll be a solid circle or a square bracket, whatever one you're using, and the numbers that are less than are to the left. And with my notation, it would be -infinity to 1, and I'll put a square bracket at 1 because it can equal 1. We do use inequality sometimes when we're talking about domain. Remember when we talked about certain things have risk factors for domain. If the equation was just y equals x minus 6, there's not a risk factor. The domain would be -infinity to +infinity. But on our last quiz, we said if it was 1 over x minus 6, we would have a risk factor because you can't divide by 0. So we would say x minus 6 cannot equal 0, and x cannot equal 6. The same is true with square roots and even roots. They have risk factors because you cannot have a negative underneath a square root. So what you do when you see a risk factor like this is we're going to write an inequality. When you see the square root of x minus 6, you should be like, oh, wait, this guy cannot be negative. Well, another way of saying that is x minus 6 must be greater than 0. That's telling us it can't be negative. It has to be positive. Then you can solve this equation by adding 6, and x would be greater than 6 would be the domain of this guy. So the domain would be x is greater than 6, or you can say, well, it can be anything bigger than 6 all the way to infinity. Now, this one is a little bit different because there are actually 2 risk factors. The first problem is the 3 minus x has to be positive. It has to be greater than 0. But usually, I did that last problem wrong. I'm sorry. I said x minus 6 had to be greater than 0. It actually could equal 0. So that would have been x has to be greater than or equal to 6. Solid dot. Because square root of 0 is just fine. So I apologize. I messed that up. So 6 to infinity with a square bracket. This is the one where it can't be 0. 3 minus x has to be greater than or equal to 0 just because of the square root, but it can't be 0 because you cannot divide by 0. So that can't equal 0, and it has to be positive. So that makes it just greater than 0. There's 2 ways you could do this. You could just add x to both sides, but if we want to practice flipping the inequality, it would be -x greater than -3. Divide by -1 and flip the inequality, and it's x is less than 3. So the domain would be 3 would get the open parenthesis or open circle, and it's shaded to the left. So the values that can be here are -infinity to 3 with a parenthesis. I'm sorry, I made a mistake on that first one. Okay, compound inequalities just mean 2 inequalities at once. And there are a couple ways that this could look. There are and inequalities, and there are or inequalities. So a number, let's say 3. 3, let's pretend x equals 3, okay? 3 is bigger than 2. And 3 is less than 4. So we can say both of these at the same time. So because we can say both of these at the same time, I can say 2 is less than x, which is less than 4, and 3 would fit into that graph. When you graph it, all the numbers that are between 2 and 4, we could do the open circles here or the parentheses, and it would be all these numbers, and 3 fits right in there. I say that that graph kind of looks like a sandwich. You're going to see why I say that in a minute, because the word and is in it. But ands mean both can be true. You can write it as a super inequality, or you can write it out with the and in between it. Either way is fine. And its graph kind of looks like a little bar. Both things can happen at once. Now, let's say I have an OR graph. Let's say I'm talking about 3 before, like I was before. And this time I say x is bigger than 2. Or I'm trying to think if I wanted to do this. I don't want to do bigger than 2. I want to say, pretend I did the sign wrong. I'm going off the cusp here, guys. X is less than 2, or x is I don't know. I can't use 2 and 4 again because that would be in the middle. We're switching this up. Mrs. Bruno should have better notes before she started. Let's say that we're talking about x is less than 2 or x is greater than 4. This is an or statement. What numbers could I be talking about here? Well, let's look at the graph and see if you can tell me. If I graph both of these, 2 is here, 4 is here, x is less than 2 would be over here. X is bigger than 4 would be over here. 3 is not that. There's no numbers they have in common. If I pick 0, it only makes this one true. If I pick 10, it only makes this one true. So that's why the word or is so important. We cannot write it like a super inequality. You just write it separate with the word or. And I think that these all look like oars of a boat. If you could pretend that there's a boat right here, you can see they kind of look like paddles. And when I write the solution set of these, what I'm doing is a picture of the graph is what the graph could be. It can be negative infinity to 2, and then there's the u for the boat, 4 to infinity. On this one, it's only talking about the numbers in between 2 and 4, so it would be 2 to 4 with the parentheses. This one has to be separate. So an and can be what they call a conjunction because it's together, and an or is a disjunction, which would be separate. That might have been a little confusing because I did the bad example, but let's see if we can figure this out here. First of all, this is written as a super inequality, so I know it's going to be an and. I also know that when I'm done, the graph is going to kind of look like a sandwich somehow, a bar of some sort. So what you can do when they're written like a super inequality is you can either write it out separate into 2 separate ones, or you can just subtract 5 from all the sides. So now I have negative 8 is less than 2x, which is less than 2. Now I divide all the sides by 2, and I get negative 4 is less than x, which is less than 1. Numbers can be less than 1 and bigger than negative 4. This is an and. If I graph it, I put the small number, then the big number. These are open parentheses or open circles because there's no equal, and it's the values that are in between. So what values am I talking about? I'm talking about all the values from the small number, negative 4, to the big number 1. That would be my solution set. If you look at this guy, which is an or, I'm expecting it to look like oars of a boat when I'm done. and it can't both be true. So you have to write it separate. So we'll have to separate these and do them separate. I get 2x is less than equal to negative 2 divided by 2. X is less than equal to negative 1. On the second guy, when I add 5 to both sides, it's 2x is greater than 6 and x is greater than 3. When I graph these together, it's going to be an or, so it's going to look like the paddles. You put the small number and you put the big number. This time, I get a square bracket at the negative 1 because it has the equal and it's shaded out here. And I get an open parenthesis at 3 and it goes on the outside where x is bigger. If I was going to write it in interval notation, what is my picture? It's a negative infinity to negative 1, and that gets a square bracket, not a parenthesis. Then comes the boat, the U, and then a parenthesis 3 to infinity. So that is an example of an OR graph. Okay, there will be some word problems. They're not too hard. I like to treat them like an equal sign sometimes and then go back and figure out when it's a better deal after the fact. So I'm not too worried about your equations, but make sure you realize that these are inequality type of problems. So Natalia can be paid in one of two ways. She can get $2.50, that's the initial condition, plus $10 an hour, or she can get $20 an hour. If it takes N hours, I put H, so we can change that to an N. If it takes N hours, when is plan B better? So when is this one worth more than that one? You could do a table and guess and check, or you can solve the inequality. 250 plus 10n is less than 20n. When you subtract 10n, you get 250 is less than 10n, divide by 10, and you get 25 is less than n. If you switch it around so that the n is on the left side, the alligator mouth is eating the n. Anytime it's more than 25 hours, she'll get more money by using plan B. So that's how you solve those equations. Okay, inequalities aren't too bad. I think you'll like them. If you have questions, we will have a whole work day tomorrow.